Okay, I wanted to talk about using the greatest common factor to rewrite an expression using the distributive property. All right, so suppose you have a addition expression, 42 plus 36. All right, and the instructions might tell you something like rewrite this expression as a product of two factors, one of them being the greatest common factor. It might also say rewrite using the distributive property and the greatest common factor. You might see this question written a couple different ways. So your first step is to find what the greatest common factor is. Now, in class, I always talk about your factor trees being kind of the be-all end-all way of finding common factors. So I'm going to show you that over here. So I'm going to do my prime factorization for 42. I'm going to start with a factor pair of 42, 6 times 7. I'm going to see if I have prime factors. 7's prime. I'm going to circle it. 6 is not prime. I could break that down into the factor pairs of 2 and 3. 2 and 3 are prime, so I'm going to circle them and I'm done. So the prime factorization of 42 is 2 times 3 times 7. All right, now I'm going to repeat that process for 36. So I'm going to start with a factor pair that when I multiply together equals 36, 4 times 9. Neither one of those are prime, so I need to break them down more. 4 can be broken down to 2 times 2. And 9 can be broken down into 3 times 3. So my prime factorization is 2 times 2 times 3. About to run out of room here. Times 3. All right, now to figure out what my greatest common factor is, I'm going to look for the prime factors that show up with both numbers. Switch colors here. So I have a 2 here. I have a 2 here. And a 2 here. I have a 3 here. I also have a 3 here. I have a 7 up here, but I don't have a 7 down here. So I'm going to see what I circled or underlined here in both numbers, and it's 2 times 3. So my GCF, my greatest common factor, is going to be 2 times 3, or 6. All right, so that's the one piece of information I need to come back to my main problem. Now, you remember the distributive property is A times B plus C equals A times B plus A times C. So the A in this case here is going to be a greatest common factor. So that's going to go outside the parentheses. Now what goes inside the parentheses is what I'm going to call what I have left over. So I factored out the 6. So now I'm going to figure out what I can multiply by 6 to get the 42. I know that 6 times 7 equals 42. So that's going to be my first chunk, because 6 times 7 is 42. Now I'm going to think about what I can multiply by 6 to get to 36. Well, that's 6. 6 times 6 is 36. Now, before I say I'm done, I'm going to check to make sure that these expressions equal each other. So I know that 42 plus 36 is 78. So this right here should equal 78 as well. So my parentheses tell me to do 7 plus 6 first. 7 plus 6 is 13. Then I'm going to multiply that by 6. All right, so that's how I know that these two expressions equal each other. Because whether I do it here like this or I do it up here like that, okay, I am still going to end up with 78. All right, let's try one more. All right, so let's do 25 plus 100. I'm going to rewrite this with the greatest common factor outside the parentheses. And what's left after I factor it out inside the parentheses. All right, so I'm going to skip the steps where I use the factor tree because I know that 25 is also a factor of 100. Sometimes you don't have to do the factor trees. However, if you are not sure or you just want some proof, go ahead and do the factor trees. But I know that 25 is a factor of 100 because if I count by 25, I say 100. So 25 is my GCF. That goes outside. Now I have to figure out what I can multiply by 25 to get to 25. Well, 25 times 1 and 25 times 4 equals 100. Let me do my check to make sure that both expressions equal each other. 125 and 1 plus 4 is 5. 5 times 25 is 125.